And continuing here, I think this is our last page. Let's solve this equation. So I have two logs on the same side. I'm trying to take those two logs and combine them into one. It is addition. So I take the arguments, the stuff in the parentheses, and I'm going to multiply them. So that'll be log of x times x minus 3. All of that would still equal 1. We can distribute inside the parentheses. Log of x squared minus 3x equals 1. Now check it out. Whenever it's log and there's nothing in the base specified, it's always going to be 10. Always. If there's nothing there, drop a 10 for log. Now let's go from log form to exponential form. We can say 10 to the power of 1 equals that. So 10 to the power of 1 equals x squared minus 3x. 10 to the 1 is just 10. And why don't you subtract the 10 to the other side? That'll give us 0 equals this here. Now recall your properties from Algebra 1, where we can factorize a trinomial expression, in this case, into these binomials. Now, two things are being multiplied and the answer is 0. That means this is 0 or this is 0 or both. So by the zero product property, you set each of the two factors individually, one at a time, equal to 0, and you solve those two equations. So these are the possibilities. X is 5 or negative 2 or both. So quick check. Recall that for an expression like this, log AB, neither of these values can be negative or 0. They must be strictly positive. That's why negative 2 is trash, because if you drop it right there, you're logging a negative number. Nuh-uh, no good. 5 is legit, because if you plug it in, it just works. So x equals 5. How about here? I have two natural logs on the same side. I'm trying to mesh them into one. They are being subtracted, so I'm going to do this property here. So ln of p stays the same, and these two logs become one log, but I'm going to take this argument in the top and that argument in the bottom. Now check it out. Log, I have one log on each side, and it's the same type of log. So the ln's vanish, and you're basically left with p equals that. So we can say p equals 6p minus 7 over 4. Solve this equation. I would drop a 1 under the p and cross multiply. So that would be 4p equals whatever that is. 1 times that is just that. Let me subtract the 4p and add the 7. That'll be 7 equals 2p. And so p equals 7 over 2. You could always check this answer to make sure it's positive or that it creates positive arguments. This would be good. This would be good. This is legit. Now, let's finish this video with a slightly different topic, and that is the idea of inverse functions. Recall from earlier math classes that if you want to find the inverse function, one method is to switch x and y and to solve for the new y. So, you see how this is called h of x? Just pretend it says y. And now switch x and y. And so now the goal is to solve for that brand new y. Let's get that y alone, and whatever we get will represent the inverse. Subtract the 4 to the other side, please. So I have this here. Maybe I can switch the left for the right. I can just swap the complete order of this equation. And I do that to make it clearer that what we have here looks a lot like this. This is an exponential form. I want to get y alone. So instead of exponential, let's rewrite this from exponential to logarithmic. And that would say log base 6 of x minus 4 equals y minus 1. So now add the 1 to the other side and y is isolated. So if you add the 1, it'll be log base 6 x minus 1, x minus 4 plus 1 equals y. But final answer would be this. Instead of y, call it what it really should be. It's the inverse of the original function h. So this is log base 6, x minus 4 plus 1. So this is the inverse function called h inverse of x. One more. Here, let's pretend this says y. And let's switch x into y. Something like that. And immediately solve for y to finish this video. Subtract the 5 to the other side. Something like that. And anytime it's natural log, the invisible base is e. Let's switch left for right. ln of e, 9 minus y equals x minus 5. What we have looks like this. Let's make it look like that. Let's go from log to exponential form. So that'll be e to the power of that equals 9 minus y. Subtract 9 to the other side, like that there, and I have negative y. Now I want y, not negative, so divide every term by a negative 1. That'll turn this into a negative and that into a positive. So it'll be negative e to the x minus 5 plus 9 equals y. But of course, this is not really called y. It should be called f inverse of x. So final answer, f inverse of x equals negative e to the power of x minus 5 plus 9. So I went very quickly through all these problems. That's like a month of math in like 20 minutes. So rewind the video. If you have to, pause it, slow it down. Let me know if you have any more questions and I'll gladly help.